Welcome to the part number 3 of Secure Software Engineering, how to correct the processes. This session is about threat modeling and secure design. The agenda is as follows. We will first discuss elements on threat modeling, and I will explain how to perform threat modeling. There are different approaches with different levels of completeness and technical viability. And we will see how to approach this. I will expand a little bit on the rating process, since the risk-based approach within the threat modeling activity is the most important aspect. We will then switch to the second part of this session, which is about secure design and secure design, and we will review design defects, and we'll also talk about design patterns and security architectures. So how can we describe the security elements of a software concept, of a software architecture, in such a way that there is some consisting information. Threat modeling defines the security objectives of the software and helps focusing the limited resources to the most critical security aspects. So as I mentioned already, at the core of threat modeling is the idea that you will not be able to make a software 100% secure. So it's important to identify the biggest threats for the software. The biggest threats means we need a rating when you use a risk rating for actually rating the different threats. So you will see there are different phases within the threat modeling activity that you need to apply, and we will review these different elements. Have you had some experience with threat modeling in a previous lecture?
It's like assessing, verifying where the threats are. It's like prévoyer les incidents.
Yeah, c'est ça. Indeed, we will try and estimate where attacks would typically happen, but this is primarily a paper exercise, and I will explain how this happens and what to do about it. Threat modeling helps understanding possible attacks. So it's helpful to use threat modeling to design the security infrastructure of an IT system. To do this, developers have to step into the shoes of a potential attacker. That's what I mentioned earlier this morning. Still, it is impossible to anticipate all kinds of attacks. So it's difficult to aim for a complete review or complete understanding of all attack models. And threat modeling supports the design process, providing a systematic method to analyze the system's security. So threat modeling should be applied in the design phase of the software development. So wherever you do design, in Waterfall or in Scrum, whenever you do design, you should at some point in time perform threat modeling. Threat modeling results improve the development process. Threat modeling should be used iteratively. So I would say a good start is to have a threat modeling exercise done once per product. If it's a project, then typically you do it only once, because you develop the software just for a specific purpose. If you have a real product where you have ongoing versions and updates, then you would actually do it frequently. So you would update your threat modeling over time. So we'll review the results you had last time and maybe add or change it correspondingly. It starts early in the software development lifecycle to identify critical security requirements and to evaluate design and implementation alternatives before any code is written. So typically you would do a software as a threat modeling before you start coding, because coding in some way limits the architectural alternatives you have. If you started coding, you're maybe fixing different things. If you're ready to throw away what you've coded, then of course, as you do it, for example, in lean development, then you would, of course, you can do it, and at the consequence, you can apply threat modeling later in the process. At the consequence that you might need to rewrite certain elements of the software. It forms also the basis of risk-based testing, because the risk evaluation that you will apply here is necessary for ranking the different threats, and this same ranking is also used for the corresponding tests later on, the security tests, to verify that specific security capabilities are there. So you can see more or less the idea is threat modeling identifies threats. You from there deduce requirements for your software, maybe additional requirements that you did not discover so far in your requirement analysis, and then this will be tested later on whether these functional or non-functional requirements are actually there. And so the threats that you have identified should at the end in the test be covered and should not be there anymore. As a rule of thumb, about half of security problems arise from implementation and configuration, so everything which is later than the design process. The other half is caused by missing or wrong requirements or fundamental design faults. So that's the experience, and from practice, half of the security issues have their origin in an early phase. So either in requirements engineering, missing or wrong, or in a design. Only half of them are coding or implementation. So it's very important to put some emphasis on these early phases. Okay, so let's look at the process. How does it look like? You have five big steps. Identify assets. Describe an overview of the architecture of your solution. Decompose the system. This is specifically meant towards finding the trust boundaries, so which components should belong together from a security point of view. Identify and rate threats, and plan mitigation, so find countermeasures to address the security issues that you've identified. So let's go quickly to each of these steps. So in the first place, you should identify the assets. So what are the most important elements within the software? Elements could be information, could be capabilities, could be properties of the software for the different stakeholders. So an asset view is very helpful because it helps to abstract specifically developers from a technological layer. Typically, developers think in features and in programming languages, and if they think about an attack, it's something very concrete like an SQL injection, for example. Whereas here the idea is what could happen bad, which bad things could happen to the different elements that you're using. For example, in your case, an asset would be the health of a driver or the health of the carpooler, the one that joins the car. That would be an asset, and this is something that could be harmed or could be destroyed or could be risked. So therefore, this is things that should be put in place. Or, for example, also in your case, could be the money of one of the persons. So it could be stealing money or trying to get someone there to steal its money could also be something happen. So this is the idea. Don't think in technology at this point in time. Think really about abstract values the assets, the values that you're talking about, that you want to talk about. And then you look at potential stakeholders, not stakeholders that are requesting security requirements like we had it in the first exercise, but now stakeholders in the sense that they may be potential hackers. So potential people that may have some interest in harm you or harm the asset that is in question. So it could be burglars, it could be organized crime, it could well be competitors also when you're talking about company security and so on. Yeah. So it's important to identify these different players, these potential hackers, these different hacker groups. Why? Because their the, the way their motivation may be different depending on which group they're belonging to. So if they're burglars, they may have a different skill set and a different motivation than if they are coming from organized crime. So therefore, for the rating later on, it's important to know the stakeholder slash hacker groups, because you will attribute certain elements to these stakeholder groups to be able to evaluate the probability of an attack. So, to repeat, in this first step, we need the assets and the actors. Let's call them actors, not stakeholders. The second stage then of threat modeling is to create an overview of the architecture. An overview of the architecture is more or less a component view. So if you have been working with these different architectural view concepts for describing software, then use a component view, and you add then additional trust boundaries, for example, additional information. Very important is I wouldn't at this point in time I wouldn't use the roles and the usage scenarios. It's really important to have a picture, something visual that you can actually handle, so that you have like a use case diagram, but with more with all the technical elements described. So the ideal, my experience is it should actually combine the major use cases, the component view, as well as the use cases, component view, as well as a flow diagram. But this is rather difficult to combine this into one picture. So let's try and be as good as you can in describing these elements. We will try this out for your solution later. I think, and this is something I would like you to assist you, because this is important to make it in such a way that you can work with it. And the idea, as I said, is that you can actually identify trust boundaries. So which components within such an IT landscape that you're designing will actually be able to trust each other. In your situation, it's going to be rather simple diagrams, because the solutions are going to be simple. So you maybe have 1 or 2 trust regions, but in reality you may have 4 or 5. So if you're looking, for example, at a modern IT scenario like autonomous driving, where there's many different components involved, and servers and architecture and backend systems, then you have very different, maybe 5, 6 different trust boundaries in that picture, because you, for some reason, for some elements, you would rather rely on a certain service, but you would, on the other side, not want this service to know the itineraries that you have followed, where you currently are, and so on. So this is more complicated. But in your case, it's going to be simple, so easy enough. Don't expect any really rather complicated picture here. So once we have this, exactly, this is now the exercise to draw the trust boundaries. The second is to draw the architecture, and the third here is to to decompose the system in components that trust each other. That's step number 2. Number 3. Number 4. Now this is the core of the threat the threat modeling. It's about threats. And there are many different methods actually to identify threats. I will talk about that later. You need to document them. I would recommend to use an Excel sheet again, very similar to what you have for the requirements. And you must rate them. And Excel sheets are very helpful in that case because you can rate them and then you can apply automatic computations for estimating the overall risk. And the traceability of the documentation shall be assured, of course, but this is for documentation purposes. So actually, this is identifying the threats and rating the threats. These two very important elements, not described here. I will describe them later. But this is the major step basically. But the other phases need to be well prepared so that you can actually then be successful in that phase. And finally, of course, you need to plan mitigation. So once you have the threats, you need to identify what you do against them. So you can either deduce a security requirement and put it on your requirements list, or maybe also deduce architectural elements. So you say, okay, this is not a requirement per se, but I need to design my architecture differently than I originally thought to address this threat, so that it cannot happen. I would recommend to describe it as an additional new security requirement. So if every time you get a threat, you add a security requirement, and the security requirement again comes down to your other list, where you say, okay, these are input from threat modeling, and then complete the list from this morning for the new threats, so to say. So how to identify threats? There are checklists, obviously. So there's plenty of people that have thought what you could do. So you could look at checklists. You could use tools. You could do brainstorming, and I will explain this. And you could use more sophisticated approaches that aim to be complete, or that aim actually to have more a theoretical background, and the hope is that if it's theoretically sound, it will help increasing the value of doing the exercise, but it's very expensive in terms of time that you need to spend with this. And one is data flow diagrams. So you would actually try to analyze the data flow in your architecture, in your software that you're planning, and then analyze formally where potential attack points would be, and use these for describing then the threats. Or use fetch trees, and I'll come back to that as well. This is a concept which comes from, which has been transferred from error trees, from fault trees, and the idea here is that by having, in every time that you go down the tree, you need a complete coverage of all potential alternatives, so that at the end you can demonstrate that every potential alternative of the user scenarios is covered. This works well for, say, antivirus solutions, for example, how to treat them, but for unknown areas, like when the architecture is not yet finished, or there's only a first attempt of the architecture, is rather difficult. But let's spend some time on the different activities. So brainstorming, you know probably brainstorming. This is a generic technology for creativity. In this case, I would apply it as follows, namely that the participants have the task to break the system. So they should change roles. So it's important that they assign themselves as now being hackers. And if you have, as I explained earlier, if you have identified different actors, so different potential hacker groups, then each of the participants should have a different hacker group role. So, for example, a burglar, and you would be one from the organized crime, and you would be a competitor of your organization, and so on. So that you actually try and think as a hacker with that specific background and join forces to get to break the system as good as you can. Brainstorming has some rules, so you need to create some flow, and you create the flow um, uh, by following some rules. And the most important rule is that you don't interrupt people. So you actually need to let the others speak what they can. You can add new stuff, you can extend it, you can have new ideas, and you throw out the ideas, but you're not allowed to criticize people and to discuss whether this is actually valid or useful, or whether is it actually realistic. We don't care. We just really write that up, and at the end you have a list of, I don't know, 20, 30 potential threats, maybe 50, depending on the length of your exercise. So I'm in student exercises, and I'm running this for maybe half an hour. So the first 10 minutes, everybody is very easy, it works well. Then 10 minutes is difficult because there are no new ideas, and we want to stop, blah, blah, blah. That's finished. And if they go on, then they get another 10 minutes where they get 5, 6, 7 very good ideas again. So you need to withstand this first level of depression, that no other ideas will be coming, and so to wait a little bit more until it's really getting through. I've done this exercise for a half day in industry, and my God, this was really interesting to see. So people start really after an hour and a half to identify with their role. They start going out looking for other material. Uh, they're trying to break the system in advance already technically. So it really works well. So this is really, I think it's an excellent exercise for this. Here are the rules. I don't need to read this, but brainstorming is very well suited for identifying the threats and threat modeling, assuming that you follow the rules. And one of the rules is the different actor groups, hacker groups shall be represented by different people in the group, and of course don't interrupt. A more technological approach, as I said, is data flow diagrams. There are different levels of data flow diagrams, and you can. This looks like this. This is a level 0 context level for a shop. It's not very helpful. Um, and at diagram 1, it becomes more interesting because you start then to detail and to break down into the different elements where communication actually happens, and you could even go down to level 2. I think my personal view is on this compared to the brainstorming approach. Since you have the people that know all this in their mind without having written it down in the group anyway, they will find the right things when they sit in the brainstorming. This is valuable if you want to document this, but the document exercise for doing this upfront to the discussion is very high because you need to describe all data flow diagrams. There are some tools that generate automated data flow diagrams out of software, but the drawback is you need the software to already done. Whereas typically, as I explained, it's more useful to use threat modeling early in the process when you're not having software or not much software, only a few pieces. And the last one is threat trees, and I've always talked about that one. This is based on hardware fault trees, and each leaf of a threat tree then represents a basic threat. And every time, as I mentioned, if there's an alternative, go left or right, you can by this. They must be completing each other, so that you for every time you go down, you can decide. You can say either I need to go to left, right, or maybe middle if there's a third, and then you have a total completeness covering alternatives. This is good for cases where you have only few alternatives to take when using software. It's not very useful if you have, like in most of your cases, you do not know how many times the interaction with the users are going to be. So especially in your case, if customers are looking up things or maybe ordering things or so, yeah, I don't know how often that may happen. So moreover, this covers not the administrator. This requires to cover administrator roles as well. So if you role admin or not, and so it makes it pretty complicated. So it's theoretically good, but in practice, I think it's not very useful. Okay. So this is the process of threat modeling. Right, so this is the overall view. We're just coming late, so therefore, very shortly identify the assets and the actors. So assets are abstract assets, so like health of people or money or things like that. And actors are the different groups of hackers. Architecture overview is decompose the system. Having an architecture overview is to describe a component view, for example, and with the most important information flow elements. Maybe also if you are able to visualize this jointly with some use cases, that's helpful. But this is very helpful for the threat modeling exercise to have a picture of your system, where you describe the different elements and where you could break into. Decompose the system is then draw trust boundaries, so say these parts belong together, and between these and these I have a trust relationship. So everything that comes from in here I trust, everything that comes from outside I don't trust. Rate the threats. You've been here. First step, identify. I would recommend brainstorming, and rating I will explain later, and finally plan the mitigation means finding countermeasures. Okay, so let's see on which attacks should be considered. So this is from Microsoft, and you can see that this is very much oriented towards operating systems and maybe also Office programs, not so much for general web applications or even mobile devices. But still, it is very old and it's very helpful. I would it helps you identifying really interesting cases. Even at the beginning, it seems to be a weird exercise. So you should consider the following attack types in the threat modeling. So if you identifying threats, for example, you could say, I want to have at least 2 threats belonging to each of these classes. I want 2 spoofing attacks, 2 tampering attacks, and so on. Just to be complete, to think about all the different ways of attacking a system. Obviously, you have much more, but this helps starting the process to work. So that you in the exercise you think about specific elements first. So let's maybe review them shortly. Spoofing is an attack where the attacker uses someone else's identity in the system. Tampering is attacks changes data for whatever reason. Repudiation, an attack where the attacker denies a transaction that was performed already. So you notice security, basic security stuff. Information disclosure, getting information out that actually should be confidential. Denial of service, elevation of privilege, get more rights within the system. So this is, you could use different ones. There are a number of classification elements. You could also use the OWASP top 10. You could say, I'm taking the OWASP top 10 as a basis, and I want to have, for each of the OWASP top 10, an attack type that would work in my system. I would use that in generically speaking, because I'm using a database, I will do some injection for manipulating blah 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 blah. Stripe, Overstop 10, there are others. We don't care. It's just about creating enough ideas for identifying threats. So now to the rating. So the last important point that is still to be done. The rating is very individual. So here is the rating, a very simple rating. You have a number of questions, 5 questions, and for each of the questions you answer them with low, medium, and high. You would actually then sum up the numbers, and if it's a 10, then it's important also. This is a generic way of doing a rating, 5 questions. Why 5? Because of Microsoft's DREAD approach. DREAD is 5 numbers, 5 letters, and DREAD is an approach from Microsoft for very early risk rating, namely, these are the initials. It's trying to answer these 5 questions, and you rate them to 1 to 3. How great is the potential damage? How easy to get a potential attack to work? How much effort and expertise is required to mount the attack? How many users will be affected? And how easy it is to find a vulnerability? 5 categories, 5 questions, 1 to 3. So that's DREAD, how it worked originally. The problem is, do I have it here? No. The problem is, DREAD is dead. Sorry, it's here. DREAD is dead because if you look here at these 5 questions, they're covering 2 dimensions. They're covering a probability dimension and an impact dimension. So some of the questions relate to how probable is it that we're going to have an attack, and other question is related to how big the damage will be. So which of these questions to you, which of these 5 are relating to damage, and which of these 5 are relating to the probability?
So this will help us to have a rate to classify the threats.
Yeah.
To know which one is priority.
And which one are related to damage? You say the first one. First one, damage.
How many users will be affected?
Yeah, damage. Exactly, damage and affected users. These are questions towards the damage, whereas how easy it is to get the attack to work, how much effort and expertise is required, and how easy it is to find vulnerability are aspects that relate to the probability. So the issue is not, when said DREAD is dead, that these questions are bad questions, but they're mixing up 2 dimensions. They're putting it on the same line, which is not a good idea, because then what you like to have is you need to weigh the threats according to their probability and their damage. So you have damage, maximum damage with very low probability, maybe critical, but if the probability is really very low, I won't care. Whereas average damage, average probability, that will cost me money, because it will happen often and probably with a high probability, and it still has, every time it happens, it will have some significant impact. So therefore, we actually need something better. And what I would recommend is the OWASP risk rating. OWASP, you heard about that? OWASP has developed a methodology to actually identify rating factors for for judging the probability and the impact of a threat, of a vulnerability. It originally comes from rating technical vulnerabilities in systems to give it a score, but the CVSS score, the Common Vulnerability Scoring System, has overruled this one. But this one is even better suited for threats, so you can use it much better in an abstract manner than the CVSS. CVSS is for rating rating abstract scenarios, very difficult because it asks a number of questions which are technically related. But here you could easily see how this actually works. Namely, you have the first line, the first big line is about vulnerability factors, whereas the second big line here is about impact factors, right? And then you can impress numbers. So there's a description on the website with examples what you could express and so on. This would then be combined. These are the likelihood or probability elements. They are on the bottom here, and the impact level here would be here, and then you combine these to one of these elements, and then ultimately you would have threats rated by being in one of these elements. Or you express the numbers, you compute them exactly, you multiply 9 to 9, so maximum would be 81, then you have a ranking for the threats. So, what I would like you to start now is to work on an architectural overview. So create one picture, an architectural overview of the components of your system. Identify the trust boundaries. They may be trivial, but nevertheless, you should identify the trust boundaries. And identify identify 2 threats, only 2 threats for the moment. You will need to do the real exercise later for the homework, but just for having, again, like this morning, identify 2 threats for having entries so you know how the process works. And don't use OWASP risk rating. Use these 5, but aligned to probability and impact. Right? So 1 and 4 and 2, 3, 1 and 4 is one dimension, 2, 3, 5 is the other dimension. Okay, so then we end up with a table with 2 lines with 1, 2, 3, 5, 6, 7, 8 columns. 8 columns. Well, first column is the name of the threat or the description. Then you have these 5 factors. Then you have the average probability, the average damage, and the combination of both the multiplication as a risk score. I'll give an example later. Okay? Okay, so let's start. 45 minutes.